Hello and welcome to all of you on my this new YouTube channel. So for today we will discuss induction surface hardening process. So for today first we will discuss introduction of induction hardening. Thereafter we will go for mathematical modeling of induction surface hardening. Then metallurgical aspects and unbalanced diagram. Thereafter, we will discuss review of practical application such as conical mandrels, internal surface of steel tubes, steel sections, circular saw, gear wheels, and at the end of this lecture, we will discuss the conclusion of this induction surface heating process. So, first we will solve stages of this induction surface hardening process. So, surface induction hardening represents the most interesting application of induction heating, making possible to achieve thin surface layer with different mechanical properties in comparison to those of core material. So, after doing this process, you will get a thin layer having different mechanical properties than the core material. The process consists of fast heating of the layer to be hardened up to a temperature higher than the upper critical temperature, making possible to form austenite structure. Second one, holding the body at this temperature for a sufficient time in order to obtain a structural equilibrium in that region. Subsequently, fast quenching in order to cool intensively the structure is stable at high temperature, or one conveniently transformation that is nothing but martensite structure. So now we will talk features of this induction surface hardening process, possibly to localize the treatment within a surface layer of the body facing the inductor. Second one, thickness of the hardened layer depends on frequency of field current, power density, material properties of the raw material, and the heating time. Third one is big volumetric joule losses achieved by using of high frequency field currents and short heating times makes possible to obtain requested very thin hardened layer. If we will talk about optimal parameters for this induction heat treated process, so there are no simple general rules that allows to define optimal parameters of this process. Distribution of the eddy current in the treated body and the optimum values of the heating time, the time interval between the end of the heating and the beginning of the quenching, and the quenching velocity. Besides, on the material properties, these elements depend on the shape of the hardened body, the presence of holes, teeth or edges, the thickness of the layer to be hardened, the distance between the inductor and the workpiece surface, the position of the inductor edges, etc. For better understanding of this process, I am showing you an image from practical induction hardening process. Here you can clearly see the gap between the inductor and the workpiece. It is necessary to have the gap, otherwise if these two comes in contact there will be short circuit, so it requires to have a gap. Okay, so now we will see what are the main factors which affects the results of induction surface hardening process. So the first factor is the grade of steel. Steel grade plays a vital role to achieve quench hardness. So the first factor is steel grade. And the second one is value and distribution of the temperature in the hardened region. Third one is the speed of quenching. So in our process in induction surface hardening, very fast quenching takes place. Fourth one is the type of geometry of the inductor sprayer system. And the last one is the uses of inductor with flux concentrator. Comes into the selection of quenchants. So the choice of quenching fluids has the same importance as that of heating regime. This choice must be done taking into account the mechanical and metallurgical properties required, the steel grade and the shape as well as the dimensions of the workpiece. The most used quenching media are water, oil, synthetic polymer fluid, other like aqueous emulsion of oil, solution of water and salt, air, bath of salt melt, some metal melts. After completing the induction hardening, the structure of workpiece get martensite. And as known, the martensite transformation cause of volume increases. Too fast or irregular transformation induces substantial internal stresses which can cause deformation and cracks, especially in the case of complex geometries of surface defects. And the temperature difference between the quenching curves of the surface layer and the one of the core, which cools down slower, increases with high quenching rates. It causes expansion of internal mass against the hardened surface layer and a higher internal residual stresses with the possibility of the workpiece distortion and formation of cracks. So now we will talk when the process, you can say, incomplete hardening process. So the martensite is a hard and brittle constituent whose hardness is higher. So the higher is the content of carbon. However, the lower cooling rates one obtains various microstructures corresponding to the presence of various constituents determined by the points of intersection between the cooling curve and the transformation curve. In particular, for cooling rates lower than the critical one obtains an incomplete hardening in which the austenite transforms partially into the bainite and partially into the martensite. So now we will conclude the surface induction hardening has provided to distinct improvement of quality of steel elements. Second one, it is characterized by fast heating and immediate quenching. Third one, heating depth can be easily changed by field current frequency, power and heating time. The fourth one is numerical simulation seems to be a powerful tool supporting effective implementation of the process to industry. And the last one is energy efficiency is important factor deciding about practical implementation of the surface induction hardening. So the remaining content we will complete in next upcoming videos, as the video will become too long, so we will complete it to the next upcoming videos. Thank you for watching. I hope you will like my videos. If you like it, then hit the like button, subscribe my channel and hit the bell icon to get the notification of upcoming videos. Thank you for watching.